Welcome back to text processing and analysis with Python. We're going to look at lesson 4.3 in this video. And we're going to look at processing sentences, or splitting big text into sentences and working with sentences in turn. Okay, so the objective, there's only one, so I'll just make that a singular, is that students will be capable of dividing paragraphs into sentences in order to work with individual sentences. The logic is pretty straightforward. Like this, the way you do it is not hard to understand. You just take a paragraph and you split it up at punctuation marks that indicate end of sentences, right? Periods, question marks, exclamation points. In English, I'm talking here. In other languages that use the Romanized alphabet. Okay, so you split them up. You split up a big long string or text that has a bunch of sentences into individual sentences. So they're in a list. Each element of that list is one sentence. So you have as many elements as there are sentences in the paragraph, or the big text, the novel, whatever, right? And then you work with each sentence in a for loop, and you do something with that sentence as you want, whatever you want to do, you know. So the logic's not hard, right? We're going to split up the big string. We're going to loop over each smaller string, which is one sentence, since we broke up on punctuation that represents sentences. And then we do something with each sentence in turn. Okay. So we're going to jump right in to practice. This is pretty straightforward. I mean, the idea. So it says define a function that takes as input a string with a paragraph and returns as output a float. That is a floating point number. That is a number that has a decimal point, with the average number of words per sentence in the paragraph given. Right? This could be a measure of, maybe sophistication or something in writing. If you want to try and analyze two different authors, all their works, you could let Python rip through all the novels as TXT files, like you get off of Gutenberg project or something, and get like an average number of words per sentence average for each of the two authors, like Mark Twain and Jane Austen, and see how they compare. You can do that with this type of program. So give that a try. See if you can do this before we look at it together. Pause the video and see if you can define a function that takes as input a string with a paragraph or bigger, just a paragraph with at least a couple sentences, and returns as output a float, a number with the decimal point with the average number of words per sentence in the paragraph given. Ready, set, pause. All right, let's take a look at how you could approach this. So I will just grab all of this because this is only one program. Let's walk through the code a bit before we run it. Okay. So once again, we're going to define a function, which we've seen how to do quite a few times now, right? You use the keyword def for define, the function name that we want to give it, open parentheses, the variable name for the argument that comes in that we'll use in the body of the function. So we'll use para for paragraph, short for paragraph, right? But it could be any well-formed variable name, colon, right there. We have a nice little doc string to tell us what this thing does. We have an import statement to import our old friend RE, module RE. And then on 14, we split up the string into not words, because look what we're using to split up. Look at the regex here. I'm going to zoom in here. Let's look at this regex because this is important. This is you're telling re.split where you want to split up the string into different elements. And so what are we doing here? Well, we have our old friend R before the opening double quote. We have opening square bracket. So we're giving it a character class, which means one of these characters. Find one of these characters anywhere and split up the string. But I mean, you can find more than one. You can find a dot, a period, question mark, or exclamation point, right? And the reason we have to use a backslash before the period there on line 14 is because a period in regex language means any character. Any character, alphanumeric or non-alphanumeric, just any character, whatever it is. But if we want to say, hey, I actually do want a period. I want the actual period, not just any character. I want, a dot. We have to put a backslash before it. And so that backslash period means find an actual period. And I don't know if you remember from the regex lesson, or worse, I'm not sure if we've seen it since, the question mark in regex language means 0 or 1 of the previous thing. But we actually want a real question mark. So we have to put a backslash in front of the question mark there. And so that's how you say it. No, I actually want a real question mark, not just 0 or 1 of the previous thing. Okay. And then the exclamation point. I don't think it's necessary to put the backslash in front of the exclamation point, but it doesn't throw an error. So I'll just do so for that consistency there. Okay, so we're going to split up paragraph. That's the string we want to split up on with this regex. So find any of those 3 characters or any number of them. It'll split up the paragraph on those characters. Okay. And then this one right here, this is a list comprehension on 15. Like I say in the comment right next to it. This is a list comprehension to delete any empty, delete the empty last element of the list. I don't show you the list. Well, here's my paragraph. Let's look at the paragraph for a second. Here's my little paragraph. I teach linguistics, comma, including and especially technical tools for linguistic analysis, period. I teach these wonderful topics at BYU and Pro Utah, exclamation point. Where do you work? Question mark. Okay, so there's my paragraph. And what's going to happen is because it's going to split up on this question mark with our regex, it's going to leave an empty element, which we don't really want. We don't need nor want an empty element in the larger list that gets created. So the way to get rid of that is, well, one way to get rid of that is with this list comprehension where we say I for I in sentence. So give me everything, every element in the sentence that was split up, right? Every sentence, if the length of I is greater than 0. And we're using I there on length of I because we use I right here, right? Okay, so we're getting rid of the empty element at the very end, which will be caused by the fact that it's going to try and split up. It will split up on that question mark, but there's nothing to the right of it. So the thing to the right will just be empty. It'll be empty string. Okay, and then there are a couple ways to filter. So this right here, this is, remember in the previous lesson. Yeah, the previous lesson we looked at how to filter lists. This is option 1 or solution 1. You create a collector list, then you loop over the list that has the sentences, and you split up on each word, and then you append to this collector list the number of words. So this len function is a new one I don't think we've seen before. Yeah, I think we saw it once maybe with range len collection. It gives you the length, the number of elements in a collection, whether it's a list or a string. So it says, give me the number of words in the current sentence, right? We're looping over sentences here. And we're looking at each sentence in turn. We're going to split up the current sentence on white space with the string method dot split. If we don't supply any other argument in there, it'll default to white space. So split up on spaces and new line breaks and tab spaces. And that is basically creating words, right? And then we're going to append to this collector list the number of words in the current sentence. You could do this more succinctly with list comprehension. Here's number 2. Option 2, I have it commented out right now. You could do that more succinctly with this list comprehension if you like. And then when we take the len words and we sum them up, we have a list of words, right? And we sum it up and we define by the length of number of sentences, right? To get an average, right? That's how you get the average, right? With math, you sum up the number of numbers there are, and then you divide by, you sum up the numbers and then you divide by the number of numbers to get the average. Okay, and then you output that out of the function. This is a function definition, right? Okay. So here's my test string, like I just read a second ago or a minute ago. and I throw that test string or that string into the function av words, which is what I call the function up here, average words, right? If I wanted to make this more transparent, I could say average of, I don't know, whatever, average words. But if I change it there, right? If I change the function name there on line 9, I need to go change it where I actually call it right here on line 31, average words. Okay, so let me run this and see if this works. So apparently there are 8.33333 on average words per sentence. Let me just see if I can do a quick little calculation here. 6, 9, so there's 11 in that one, 3, 6, 9, 10 in that one, and only 4 in that one. So that sounds about right, 8.3. Good. Let me just print out some things here to make it transparent what we're doing here. So we get a paragraph passed in, so right, so this text string will be passed into the function, and it gets kind of renamed to para for paragraph within the body of the function, right? So it's gonna come in here. If you want to see that, let's just be very transparent. Let me just print out para right here. And if I rerun the function, I'll just rerun it. You can see that that string got passed in and is now para within the body of the function. And then after we split and get rid of the empty character or the empty string, well, let me just go ahead and be very transparent here. I'm going to print sentence, short for sentence. And if I run this script again now, I should see, let me make this a little bigger. There's the string, then here's the list with each sentence as an element of the list. But you can see once again that we have an empty element back here. It's a string that's empty, no characters in it. And once again, that's caused by the fact that we have a question mark at the very end of the string, which was used to break up strings. So it broke it up on that element, but then there was nothing to the right. So it returned an empty string. The way to get rid of that, like we saw a second ago, like I explained, was to do this list comprehension. So let me go ahead and print out sentence now after getting rid of that empty element. And now it's not there anymore. Where do you work? Now it's not there. All right, so we bring in paragraph right here, break it up on sentences, but we have an empty one back there. We get rid of that empty one there. Okay. Then I guess we can print out words if you want to see what this does. Print words. Let me run the script again. And let's look at this. Okay, so there we go. We have a list with all the sentences without the empty string. Then we look at the first element of this list, which is this sentence here, which says, I teach linguistics, including especially technical tools for linguistic analysis. It broke that string up on white space. So down here, that's what it printed out. That's why we have a list of those words as their own element in the list. I teach, second element, third element, linguistics, fourth element, including, etc. Okay, and then once we have that, we just simply got the length of it. And I'll just show you real quick. If I do print length of words. Okay, so we should have 10 elements in this list. That is 10 words in the sentence, right? Or excuse me, 11 in this one. 3, 6, 9, 11. Yeah, we have 11 words in this sentence. Down here, we should have 10, 3, 6, 9, 10, and 4. And it just took the average of 9, 10, and 4 and got 8.3. Okay, so that is a quick rundown of how you can work with sentences. Now, I will give you a little bonus lesson here of sorts, in that there is a function in the Natural Language Toolkit that does this. So let me just show you that real quick. Just a little bonus lesson. If what I just explained was pretty difficult, you may just want to stop the video and review it and really get it down to what I just did. But if you want a little bonus video here, a little bonus thing, there's a function called sent tokenize within the NLTK library. I'm going to use the word library here because it's bigger than just a module. There's a hierarchy in Python software. Libraries at the top, then you have packages, then you have modules. Modules are just basically Python files. Anyway, NLTK is a big beast, has a lot of stuff and functions and resources like corpora. It's actually the main topic of Linguistics 440, by the way. Anyway, so NLTK has a function called sent_tokenize, which takes as input a string and returns as output a list with each sentence in its own element of the list. So I'll just go ahead and run this script again. And it's printing out everything that we've done so far, every last step that I told it to tell us to print out. It's printing those things out, but it's also printing out at the bottom here, below the average words printout, right? After the 8.333, it prints out this caused by line 39. And so this tokenizes sentences as well. And it honestly does a better job than doing it manually because it holds on to the punctuation that I used to break up the string manually. It gets rid of the empty string at the end that I had to do so manually. Okay, so that's maybe a quicker way. If you don't know how to do that, you actually have to download NLTK, and it's a little bit more involved to get it set up. To call it, it's pretty easy. You can see that's just simply lines 38 and 39. But I won't go through how to do that. That's now. If you're interested, you definitely can stop them during my office hours, and I can show you how to do it, help you do it on your computer. But anyway, a little bonus thing there. There are a lot of good functions in the NLTK package library. Like I mentioned, Linguistics 440, Ling 440. The majority of that semester is we look at NLTK, that library, like 9 out of 13 chapters of the NLTK book. So anyway, that is how you work with sentences. You just simply break up the big string that you receive into sentences by looking at punctuation that end sentences. And then you just simply loop over each of those sentences and do something with those sentences as you need, whatever you need to do. Okay, so that is lesson 4.3, processing sentences. See you next time.